Welcome to MEI Modelling with Algorithms. We're on the topic of critical path analysis, and this is video 1.4, finding critical activities and critical paths. Now we're following on from the previous three videos in this topic, which you should already have seen, and firstly we'll just introduce a few pieces of terminology. The minimum project completion time, that's the minimum time in which it is possible to complete the project, and that will be the length of the longest path through the network. And any delay on this will therefore lengthen the whole project. So that is going to be referred to now as a critical path, and the activities that form that path are called critical activities. Now we've already seen how to do forward and backward passes to find the earliest and latest event times. Once we've done that, then we can work out what are the critical activities and therefore find the critical path. We're also going to introduce the idea of float in this video. Now that is essentially any spare time that's associated with an activity, or any sort of flexibility in terms of when the activity can start and end. Activities that have zero total float are called critical activities. We'll find that float becomes very important later when we're dealing with scheduling of activities, because it gives us some freedom as to when activities start and end. So if we're in a situation with limited resources, we can make sure that a resource that is limited is not having to be overused at any one time by moving the start and end times of certain activities so that they don't overlap. So how do we calculate the float for a given activity? Well, what we do is we look at the events which that activity takes us between, and if we think about it, the latest event time for the end of the activity, in this case this is this 18, so that's the latest time at which that activity can complete. And then we also look at the earliest time for event I, which is the first of the two activities, the first of the two events involved. In this case it's 4. So we've got the earliest time that the event can start and the latest time the event can finish. And if we subtract one from the other, so latest event time for J minus early event time for I, in this case that would be 18 minus 4, which of course is 14. That means that there are 14 units of time between when this thing can start and when this thing can end, but the activity itself only needs 13 units of time. So that means that we've got 1 unit of slack. So by subtracting that 13 from the 14 that we have available for it, that gives us the float for that activity, the total float, which is 1. Now in this video we're just going to be talking about total float. What you do need to be aware of though is that total float can actually be divided into two different types of float, which are independent float and interfering float. Interfering float is probably the first one to explain, the easiest one to understand, and that is that when you if you choose to change when this activity starts or ends, well, what that means is that there may be an activity which follows on from it, and by delaying this activity here, you will then have a knock-on effect onto the activity that comes afterwards. So the later you start this activity, the later you'll have to start the activity that follows it. So it interferes with other activities. It doesn't delay the overall time of the project, but it just means that other activities later on will actually effectively have less float than they would have done otherwise. Independent float is anything else. So any float that you have that is there and is not going to have any impact on any other activities is independent float, and the total is just the sum of those two. Now you'll see examples on integral in your textbook where that's been calculated. In this video, as I say, we're just going to be calculating total float. Now we mentioned on the introductory slide the idea of critical activities. What we're going to do now is we're going to look at this activity network and see if we can identify what the critical activities are. Now what we need to know is that critical activities have got zero float, so that's how they can be identified. So can we identify the critical activities here? If you wish to pause the video at this point and try this yourself, you can. Okay, so hopefully what you've found is that for some of these activities there is a non-zero float. So for example here we'd be taking this 18 and this 4, subtracting the 13 and the 4 and finding that this activity has a float of 1, so that's not a critical activity. But something like this activity here, we've got a latest finish time of 6 and an earliest start time of 0 and a timed activity of 6, so that means that that one is a critical activity. Same with this, we can see the 16 minus 6 gives us the 10, so that's a critical activity, as is this one here. All of the other ones down in this part of the network are non-critical activities. So these critical activities must be completed exactly at the time that is there for them. There's no flexibility in when they can start or end. Okay, so now we've identified those activities, we've actually also now found the critical path, which is there. So just highlighting those arcs which represent those activities, taking us from the start of the project to the end, we've got a critical path there for this activity network. Okay, so here's another example, a slightly more complicated example, larger activity network, and also before we can identify any critical activities here, we actually need to find the earliest start and latest event times by doing a forward pass followed by a backward pass. So first thing I'd like you to do is just to pause your video and see if you can remember how to do that forward pass and backward pass that we saw on previous videos, and then I'll reveal the answer to that stage. Okay, here it is then. That's what you should have got. And again, if you want to pause the video now and see if you can identify firstly the critical activities and the critical path or paths. So those are the critical activities identified. Again, remember they're just any that have 0 float. So here we look at 12, take away 7, take away 5 gives us 0. So identify that, for example, as having 0 float. And then we look for the actual critical paths themselves. And what we see here is that there are actually 2 critical paths here, because at this point we can either go from here to here to here one way, alright, and that's all critical activities, or we could go straight across. So both those options, so both the path that includes that part and that part, they are both critical paths, and so there's no flexibility at all anywhere along either of those paths. And so to record our answer, we will list the activities in order for those 2 critical paths, like that. Okay, so just a summary then, and this actually includes some of the stuff which we haven't seen in this video but did see in some of the earlier ones. So if we were doing this right from the very start in a real situation, the first thing we would do would be to think about the activities that need to be completed and create a precedence table. That was in the first video in this topic. After that, we can draw the network with the activities on arcs and events as nodes, and remember that we might need to include dummies in doing that. Then we go on and do the forward pass and the backward pass, which gives us the earliest event times and latest event times, and from there, as we've just seen in this video, we can identify critical activities which have 0 total float and critical paths. What we'll then get onto is the idea that we can assess what impact delays might have. So if it's in the critical event, if that gets delayed, it will delay the overall project, but other activities, if there's some float, a delay in one of those might not affect the overall project, and we might actually choose sometimes to delay an activity that has some float in order to make better use of the resources that are available for the project. So that concludes video 1.4, finding critical activities, critical paths. The final video on this topic will be the next one, video 1.5, which is resourcing and scheduling.